Okay, this is the second video of the quantum effects or light as a photon. And we have two more problems to do. In this one it says hydrogen has a red emission line at 656.3 nanometers. So an emission line with a distance means that this is lambda. So my lambda is 656.3 nanometers. It wants to know what is the energy, and it wants to know what is the frequency. Then, okay. Now, when we did the other problems, the unit of lambda was in meters. So the first thing I need to do is change this to meters. So this is going back to chapter 1. The fact that 1 times 10 to the 9th nanometers is 1 meter. And so this becomes 6.563 times 10 to the minus 7th meters. And yes, you need to know this, okay? So I'm going to do the frequency first because there's an equation with lambda and frequency in it. And that equation is C is equal to lambda nu. And C is that constant of 3.0 times 10 to the 8th. Or if you want to use 2.99, you can. So I have 3.0 times 10 to the 8th is 6.563 times 10 to the minus 7th times nu for frequency. So I'm going to divide both sides by this. So I have 3.0 times 10 to the 8th divided by 6.563 times 10 to the minus 7th is nu. So nu ends up being 4.51 times, 4.71 times 10 to the positive 14 hertz. Now I'm hitting the eraser too much. There we go. And the equation that links E and nu is E is equal to h nu. And h is another constant of 6.63 times 10 to the minus 34. So I want to know what energy is. So it's going to be 6.63 times 10 to the negative 34. Times the nu that I just calculated, 4.571 times 10 to the 14th, gives me an energy of 3.03 times 10 to the minus 14th joules. Okay, and so these are my two answers. Here's my frequency, and here is my energy. So I had two answers for that question. Next question says, what is the wavelength? So it wants to know what is lambda. And of a 7.65 times 10 to the minus 17 joules wave. So joules is energy. So I have energy is equal to 7.65 times 10 to the minus 17th joules. So I have an equation of energy, but not with energy and wavelength. So my energy equation is E is equal to h nu, and h again is that 6.63 times 10 to the negative 34. It's a constant. So I have 7.65 times 10 to the minus 17th is equal to 6.63 times 10 to the negative 34th times nu. And then I want to divide both sides by the 6.63, so I have 7.65 times 10 to the minus 17th divided by 6.63 times 10 to the negative 34th is equal to nu. So nu is 1.15 times 10 to the 17th hertz. And then I can relate nu and lambda using the equation C is equal to lambda nu, and C is that constant of 3.0 times 10 to the 8th. So I have 3.0 times 10 to the 8th is equal to lambda times 1.15 times 10 to the 17th. Divide both sides by that 1.15, so I have 3.0 times 10 to the 8th divided by 1.15 times 10 to the 17th is equal to lambda. And so lambda ends up being 2.60 times 10 to the minus 9th meters. And it doesn't specify the units, so you can leave it in meters. However, if I take these two equations, let me change colors here. If I take this equation and this equation together, and I solve this equation, if I divide C is equal to lambda nu, I divide both sides by lambda, then I have C divided by lambda is equal to nu, and I take E is equal to h nu, and I substitute this in, which I need to erase that, take this in and substitute in for this, I get E is equal to h times C divided by lambda, or hc divided by lambda is equal to energy. And so my energy then would be the 6.63 times 10 to the negative 34th times 3.0 times 10 to the 8th divided by my, oops, I had an energy, that's what it was. I'm going back to the last problem. My energy was 7.65 times 10 to the minus 17th, and this is my unknown, so I need to multiply both sides by my unknown. So I have 7.65 times 10 to the minus 17th lambda. When I multiply these two terms together, I get 1.989 times 10 to the minus 25th. So now lambda is 1.989 times 10 to the minus 25th divided by 7.65 times 10 to the minus 17th, and I still get the 2.60 lambda times 10 to the minus 9th meters. Okay, so either way I get the same answer. Okay, if we are doing an in-class test and I give you a formula sheet, I give you these two formulas because they're at the end of the chapter. However, I do not give you this formula, so it depends on which way you want to memorize it or not. Okay. Last part of this section has to do with photons. Photons are the particles of energy, and it's proportional to the observed frequency of light. We just saw that. We saw the fact that the E is equal to hc over lambda, and if I multiply both sides by lambda, I get E lambda is hc. These two right here are constant. So just like when we did Boyle's law, if I increase energy, then the wavelength must go down. Or if I increase my wavelength, my energy must go down. Okay? And I have a video that shows you that. Okay?
The photoelectric effect describes the effect caused when electromagnetic waves hit a metal surface, which can cause electrons to be released from the metal surface. These electromagnetic waves can be thought of as photons. Photons are small packets of energy which hit the metal surface. Each one has the potential of releasing an electron. If we decrease the wavelength of these photons, this has the effect of increasing its frequency, which also has the effect of increasing the energy of these photons. You will notice that as we get to a certain point, electrons start to be released from the metal surface. As I continue to increase their energy, the electron's energy also increases. So this graph is showing us that the energy is proportional to the frequency of these photons hitting.
Okay, so that's basically what we saw in the equation. Oops. And that is the end of this video.